Okay, in this video I'll show you how to solve basic trig equations. There will be two more parts after this on solving trig equations where they'll get increasingly more difficult. So the first one we'll look at is solving the equation sine of theta equals 1/2. And we're going to solve on the interval from 0 to 2 pi. That is, we're going to find all solutions bigger than 0 but smaller than 2 pi. So to solve an equation like this, you just draw a picture of your unit circle. And as you get better at these, you might not have to draw the picture, but just picture it in your head. And we want to know where sine, the y-coordinate, is equal to 1/2. So I picture horizontal lines like y equals. This would be y equals 1, and that would be y equals 0. So y equals 1/2 would be right in the middle there, about here. And those are my two solutions. And with a good knowledge of your unit circle, you'll know that that is theta equals pi over 6 and 5 pi over 6. And those are the two solutions to this problem. So we write our answer in a set. In the second problem, we're asked to solve the equation cosine theta equals -√3 over 2 on the same interval. So again, we'll draw a quick sketch of the unit circle. And this time we want to know where cosine, or the x-coordinate, is equal to -√3 over 2. So for x-coordinates, we're imagining vertical lines, x equals 1, and x equals -1. So we're really close to x equals -1, about as close as you can get and still be a known value on your unit circle, right about here. And those angles are 5 pi over 6 and 7 pi over 6. Just to note that these problems could be in degrees instead of radians, and then it would say solve on 0 to 360, and then we would say 150 and 210 degrees instead. And those are our two examples for example 2, or two answers for example 2. Example 3, we're going to solve the equation tan theta equals -1, still on the interval from 0 to 2 pi. Again, you always want to pay attention to that interval. So this time we're asked to find tangent. So we draw our unit circle. We don't want the y-coordinate, we don't want the x-coordinate, we want the ratio between y and x. Well, the ratio from y to x is a slope. So when I'm doing a tangent problem, I'm thinking about it as a slope through the origin, a slope of -1. So here's a slope of 0, there's an undefined slope, the slope of -1 is right about there. So it cuts right through. Of course, that's where sine and cosine are opposites, so that would be 3 pi over 4 and 7 pi over 4. Those are your two solutions. Tangent, since it has a period of pi, if you know one solution, you can always add pi to get another. 3 pi over 4 plus pi. Okay, example 4. This one, the intervals change just slightly. It says solve on the interval from -pi to pi. Find when cosine equals 0 on the interval from -pi to pi. So I'll draw a unit circle. And what's different about this problem is the way I name my angles. So I want to know where cosine 0, just like that, and normally we just say that's pi over 2 and 3 pi over 2, but only one of those answers fits the constraints given. Pi over 2 is on the stated interval. It's not bigger than pi. But 3 pi over 2 is bigger than pi. So what this is saying is I can wrap forward pi units or backward pi units to get my answer, but you can't go all the way around 2 pi units like you're accustomed to. So instead of calling this point 3 pi over 2, we call it -pi over 2 because it's like a quarter turn backward. And those are the two solutions to the problem. -pi halves, pi halves. Okay. And our fifth example. Now we're asked to solve an equation on the interval from 0 to 4 pi. So this is a little bit different because we've grown accustomed to the 0 to 2 pi, or at least an interval that was 2 pi long. So if you picture the sine curve real quick, here's the sine curve on the interval from 0 to 2 pi. And then here it is again from 2 pi to 4 pi. So if we're asking where sine is equal to negative root 2 over 2, which is like negative 0.7, we're asking where it crosses, there's like y equals 0, there's y equals negative 0.7, somewhere down there. And you can see it crosses that line once, twice on the interval from 0 to 2 pi, and then twice again on the interval from 2 pi to 4 pi. That means this problem will have 4 solutions instead of just 2. When you're using your unit circle as a visual, you'll see the first 2. So where is the y-coordinate negative root 2 over 2? Here's about there maybe. Right, and that's 3 pi over 4 and 5 pi over 4. Those correspond with the first 2 solutions here on the interval from 0 to 2 pi. So I'll put them in my list. And then I need to go and find the other 2 solutions. Well, the periodic property of sine tells me that if 3 pi over 4 is a solution, then there's another solution exactly 1 period away from it, which is exactly 2 pi larger than it, 3 pi over 4 plus 2 pi. We get a common denominator. 3 pi over 4 plus 8 pi over 4 would make 11 pi over 4. Then 5 pi over 4 is this solution right here. There's another solution exactly 1 period away from it. So if you add 2 pi to 5 pi over 4, you get 13 pi over 4. And those are your 4 solutions on the interval from 0 to 4 pi. In example 6, we see another equation that has 4 solutions, but for a different reason. So we're asked to solve 4 cosine squared equals 1 on the interval from 0 to 2 pi. So back to that same interval, but now a different type of equation. This one, cosine's not isolated. So I need to start by isolating the cosine function. And I can do that by dividing both sides by 4. And since this is cosine squared equals a quarter, and I want to know what cosine is, I'll take the square root of both sides. The square root of cosine squared is plus or minus cosine. I'll put my plus or minus on the right. And the square root of a quarter is a half. So you see this problem is going to generate 4 solutions because I'm actually considering 2 different equations. Where is cosine positive 1/2 and then where is it negative 1/2. I can still do it with my unit circle. Just want to know where the x coordinates, that one's more like a unit ellipse. Where is cosine positive 1/2? Where is it negative 1/2? And you can see that will give you 4 solutions, and all of them are pi over 3s. Pi over 3, 2 pi over 3, not 3 pi over 3, but 4 pi over 3, 5 pi over 3. Those are the 4 solutions. And it's good to get into the habit of checking these kind of things so you can plug any one of those back into the original equation, and 4 times cosine of pi over 3 squared should give you 1. Example 7. This one asks for a complete solution set. So this doesn't want just solutions on 0 to 2 pi or 0 to 4 pi, but we actually want every solution there is. So this looks like a quadratic form. If I use a smiley face, you can see exactly what you're looking at here. 2 smiley squared minus smiley minus 1 equals 0. I think that's going to factor. So if I do 2 smileys here and 1 there, that'll give me 2 smileys squared. And if I do 1 and 1, that'll give me 1. I just need to work out the signs. I want the middle term to be negative, so that means I want that product to be negative. And then this one's positive. Okay, so I can factor this first expression exactly like this. It would be 2 sine theta plus 1 times sine theta minus 1 equals 0. And this brings up the zero product property. 2 things multiplied by 0, one of them has to be 0. So one or both of them have to be 0. So if 2 sine theta plus 1 is 0, that means sine theta will equal negative 1/2. And if sine theta minus 1 is 0, that means sine theta equals 1. These will both lead to solutions. I'm going to show them all on my unit circle. We want to know where y is either equal to 1 or y is equal to negative 1/2. Okay, y is equal to 1 up here and negative 1/2 down here. So highlight that point. Here's negative 1/2. So you can see this problem is going to have 3 solutions. I'm going to have pi over 2, 7 pi over 6, and 11 pi over 6. Okay. Now, if I was asked to find all the solutions on the interval from 0 to 2 pi, those would be my 3 answers. I'd put them in my list and I'd be done. But this one asks for a complete solution set. A complete solution set means all of the answers that are a full period away from those as well. So when I list my answers, it'll go like this. Pi over 2 plus all multiples of 2 pi. 7 pi over 6 plus all multiples of 2 pi. And 11 pi over 6 plus all multiples of 2 pi. And that's the complete solution set. Now you can list these with commas, this one, comma that one, instead of unions. That's perfectly fine. In our 8th example, solve on negative pi to pi. Sine theta minus cosine theta is equal to 1. So what we're going to have to do here is we're going to have to get down to a single trig function. And right now we're in terms of sine and in terms of cosine. So this is going to be a little tricky. What I'll do first is I'll bring the cosine over to the right. 1 plus cosine theta. Right, and then I'm going to square both sides. You might wonder at first, why are you squaring both sides of the equation? That creates all sorts of problems like extraneous solutions that you don't want to deal with. But what you'll see is when you square 1 plus cosine and you square sine, there'll be a Pythagorean identity that you can use that'll simplify the problem a little bit. So this will become sine squared theta equals 1 plus 2 cosine theta plus cosine squared theta. Okay, and my ultimate goal is to get this down to a single trig function, so I can do that by replacing sine squared with 1 minus cosine squared. Then everything will be in terms of cosine. 1 minus cosine squared is equal to 1 plus 2 cosine theta plus cosine squared theta. Bring everything over to the right there. The 1's will cancel. You'll have 2 cosine theta plus 2 cosine squared theta, and that can be easily factored and solved by pulling out 2 cosine theta, leaving 1 plus cosine theta. Another zero product property argument, either cosine equals 0 or 1 plus cosine equals 0. So that gives us either cosine theta equals 0 or cosine theta equals negative 1. Okay? If we look at our unit circle, I'll put it right here. So either the x-coordinate is 0 or the x-coordinate is negative 1. And again, we're asked for solutions on the interval from negative pi to pi, including negative pi but not including pi. So I'll call this pi over 2. That's not larger than pi. But I'll call this one negative pi over 2 and this one negative pi because the inclusive end was on the negative pi end. And those are my 3 solutions. In order, it would be negative pi over 2, positive pi over 2. Okay. And that's enough for examples on solving trig equations. We'll get into some other types of trig equations that you need to know how to solve in the next part.